Good morning. This is Doug Becker with Nationwide and would like to welcome you to our webinar today as part of our Grain Bin Safety Week. This is our second year at Grain Bin Safety Week, which was established as an observance dedicated to increasing awareness and safety in and around grain bins to help reduce the number of injuries that occur with those who handle grain. Today we have the pleasure of introducing Dr. Carol Jones of Oklahoma State University, who will discuss the topic of stored grain management, grain quality, and the safety connection. From her several years of experience in research, she will provide information on good management practices of handling grain and the relationship of these important factors to our safety when handling the grain. Do feel free to submit your questions as we will click through the chat box located in the lower right-hand side of your screen. We will try to address those questions at the end of the hour. Thank you for joining us, and we'll now turn the session over to Dr. Jones.
Thank you very much. It's a real pleasure to be here today and to talk about something I'm very passionate about. The Grain Bin Safety Initiative around the United States has grown in the past few years, and it's just a real privilege to get to work with Nationwide on this. As Doug said, be sure and type in your questions, and we'll address those at the end of the presentation. I'd really like to visit with you about some of the things you wonder about. So take some notes and send in your questions, and we'll get to those. Good grain quality equals safety and profit. That's kind of a no-brainer type sentence to say, but we're going to talk about some of the things you need to look for when you think that you might be having some problems with your bins. When everything goes well, then we really don't have so many safety issues. It's when things don't go well and when our management is challenged by some other things, some other risk factors that we have our issues. So we're going to go through some of those for you today. This is not what you want to see when you look in your bin. You're unloading through the reclaim system, but you've still got these big mounds of, this is corn stuck to the walls. You really want to think to yourself, do I need to go in that bin? And if I do, what's going to happen? The sign, do not enter, is just really prevalent. That's what your employees need to think. That's what your family members need to think anytime you look into a bin. Just some facts about this safety issue. Farming is the number 6 most dangerous occupation for adults or children, either one, with the U.S. Bureau of Labor Standards. An estimated 300 children or more die each year in farming accidents. Not all of that is grain storage related. But around the farm, we lose more than 300 children each year, and that's just a really, really sad situation. 20% of fatalities on the farm are under 16 years old. That's a really scary number. And then that doesn't even mention the permanent disabilities that we see each year from farm incidents. 2010 and 11 was a challenge for the grain industry, particularly with the wet corn crop we had that year, and it certainly showed in the incidents that we had in grain bins. We had more than 50 entrapments, and about half of those ended in deaths that year. And this year, the 2014 and 15 crop, we're right on target to exceed that 2010 and 11 count. That's just poses to be a really tragic year for us. So that's one reason we really want to think about this handling and safety connection. 77% of the grain bin incidents, and incident victims happen when we're unloading bins. Generally, that's when the grain is out of condition. If the grain is in good condition, we don't need to go into the bins. The grain comes from the reclaim system with no problem. And we just don't have incidents and losses. You know, you can be trapped in 45 seconds and buried in 20 seconds. You can't even imagine how fast that goes. Tragedy happens just so quickly. There's 3 ways that this kind of an incident can happen, and all are associated with unloading poor quality grain. Flowing grain, of course, getting caught in the flow is a tragic situation. That happens faster all the time as our unloading equipment, our reclaim equipment gets bigger and faster and handles higher capacity every year. Might be a collapse of a grain bridge. We have a crust of grain at the top of the bin. We start unloading our bin, but you don't see that inverted cone. the bin. That has to be broken up for it to go through the reclaim system, and when we enter that bin, the possibility of breaking through that grain bridge is huge. One of the most common, probably the flowing grain situation is the most common situation, but an avalanche or a vertical grain wall that's stuck to the side of the bin is very common also. Flowing grain many times is an entrapment. It may not be a death. The avalanche of a vertical grain wall, the prediction of that being a death is greater than with the flowing grain. It can happen in a grain bin, or it could be in your handling equipment. A gravity wagon is just as dangerous as the grain bin is for all the same reasons. Here's a little graphic of what it looks like to be engulfed with the reclaim system on, with the auger on. You can be engulfed up to your waist in 2 to 3 seconds. There's just not enough time to react. Those of us who were raised in the grain business, and I date myself a little bit here, but things moved so much slower when we were young and we played in the grain bins. Now we move grain so much quicker, and there just isn't the time to react that we had as children. If the grain's out of condition, we go into the bin to walk down the grain, make sure that it goes down to the center auger. We get pulled into that grain flow. We just can't get out in time. So, when the reclaim system's on, you just don't go in the bin. This is a picture of what happens with a grain bridge. Again, we don't see this very often except in the corn industry. The better way to remedy this problem is to take a pipe or something to reach in through the access ports and break up that bridge. Standing on it's a bad plan, no matter how we look at it. Even if the reclaim system's off, there's going to be a cone under that bridge, and the person will fall through, and the bridge collapses on top of them. I would say 99% of the time this is a fatality. It's just a hard thing to recover someone. It's very hard to find the body in this case. This is a very common condition where the grain is stuck to the bin wall. It doesn't look like there's much grain stuck on that wall, but when it comes down on top of the victim, it can be 10 to 20,000 bushel. The weight is tremendous. That can be an injury. And of course, the tendency for suffocation to happen at that point is really high. So never want to be below the top surface of the grain. In this case, you want to be above that top level. Don't ever go down when you've got grain over your head, because that avalanche goes a lot farther than you think it will go. If the grain's in good condition, your reclaim system is designed to work without a problem. So if the reclaim system works properly, there's really not a reason to enter the bin. If we're not in the bin, then the entrapment doesn't happen. The accidents that happen on the outside of the bin, the incidents that happen on the outside of the bin can be catastrophes, but their percentage of death is a lot less than the incidents that are inside the bin. Well, here's some things you really don't want to see in your bin. We have examples of grain that's gone out of condition for different reasons, but all of those have their root problem in temperature and water mismanagement. If you can manage the water, the moisture content, and the water coming into the bin, either through condensation or leaks, and you can manage the temperature in your bin and in the grain, you've got the battle won pretty easily. We see in the bottom left-hand corner, that's a picture of grain that's stuck onto a corrugated steel bin wall. That would be a situation of the avalanche that we saw the picture of earlier. This happens with condensation at the interface of the grain with the bin wall. It can come from leaks. Perhaps a bolt is missing in the sheaths where they come together. So anytime there's moisture on that bin wall due to a temperature difference or a leak, then we can have that grain that's stuck to the wall, molds beginning to form, and the avalanche surface is beginning to build. The next picture over to the right is a picture of grain that is built as stalagmite or a tower. Some people call those soldiers. And that's just a solid piece, hunk of grain that's molded together, and some heat's built up, and more grain around it is stuck to it. Those actually can get so large in a large bin that they can fall over on people and do some injury. Up in the center, up at the top, that's a piece of molded grain. It came out of the bottom of a bin, and it just shows that when grain gets so moist that the mold starts to collect, and it just grows and grows, and that's the kind of situation that doesn't go down through the reclaim system. It's hard to get some of the big chunks to go down into the augers. In the top right-hand corner, those are pictures of grain that actually caught on fire. The one on the left shows still the mold, but the one on the right actually combusted and became burnt. I believe those are soybeans. And then in the bottom right-hand corner, that was a drip down a temperature cable in the middle of a bin, and it started to make a soldier there in the middle. And of course, that being in the center of the bin, that's right where the center sump is, and that reclaim system is immediately going to be stopped. Nothing's going to come out that center sump as long as that chunk is there. But all of these 5 incidents happened because of moisture and temperature being mismanaged in the bin. Now, that's not to say someone intentionally neglected the bin. Some years, that's all we have to store is a wet crop, and that was the case in 2010 and 11. So our challenges are even greater for management when we have grain coming into the bin in poor quality. So that's something you really need to be aware of when your crop comes in for storage, is what kind of quality do you have to deal with in the first place? Quality never, ever improves in storage. There's only 2 things that can happen. It'll stay the same or it'll get worse. Now, you could add value to that product by changing the blend or the formulation or the size reduction or marketing it at a different time. Those are all value-added steps, but that quality is the best it's ever going to be right there in the field. So if you have bad grain coming in, it's only going to get worse in storage, and that's when we begin to have our problem. So the management of temperature changes and moisture is so critical in this business. This graphic shows some of the things that you can anticipate wherever you are in the United States, but particularly in the Midwest. And if you look through this graphic, we'll go through these step at a time. Most of these things have to do with some kind of a temperature change. We'll start with the graphic says large temperature fronts. I was looking at some of my research data from this past summer. And we're in Oklahoma, of course, and I know that our weather is known to be pretty diverse. In 2 months, I had 10 days that had a temperature difference in the daily high of 40 degrees. Now, in the middle of the summer, that's kind of unusual. Any temperature difference of more than 15 degrees is going to cause condensation someplace in your product. Temperature differences of 40 degrees really give us some problems. So those large temperature fronts, when they come through your storage area, can tend to cause the bin to rain. That's when your aeration management is really important, and having the exhaust bins designed properly on your bin is just so critical. That condensation that comes down off your roof, or I've had producers call and say, it's raining in my bin. What do I do? It's dry outside, but my bin is raining. Well, that tells me that there's not enough aeration space up in the head space. So that's when you need to check your roof vents to make sure they're not plugged. Make sure that when you change your aeration system, change the fans and the motors, that you check to make sure that matches the vent space you have above. We see the moisture imbalances there as we go around to the left counterclockwise. Perhaps you're loading different moisture contents of product in on top of each other, and every time there's a difference in moisture between the layers of the loads, then that can cause condensation where those 2 boundaries meet. Of course, that's right in the middle of your grain bulk, and you don't know you've got a problem until you unload the bin, or maybe a temperature cable picks up some heat rise from the mold. Either way, it's a hard problem to remedy. So making your moisture content be homogeneous throughout the bin, in other words, the same throughout the entire bin, sure helps in keeping the moisture balance appropriate. Overdrying and shrink can happen, and what happens there for your grain quality is it causes cracking in your grain particles. Well, anytime we have fines, or fine material from the broken grain, for some reason it goes to the middle of the bin. And if you think about it in your grain storage, the fines are always in the middle and the trash is at the outside. The trash can be a problem, but not near as big a problem as that fine material in the middle of the bin. That fine material plugs up the pores between the grain, and your aeration system cannot get the air through that part of the bin. If you think about it, when you have problems in your bin, it probably starts in the top and the middle. And the reason for that is you've got those fines in the middle and the aeration system is not doing its job in removing moisture in that part of the bin. As we go around again to counterclockwise to the bottom left, we see insects. Well, insects are just like mold in that their little environment they build for themselves is a moist environment. Their body functions create heat and moisture, and that problem just gets bigger and bigger. So if you're in a part of the country where insects are a huge issue, then you need to make sure you have your pest management plan in place. You're fumigating and watching for growth and population of your insects, because they can cause just as much problem as mold can. I like that graphic down at the bottom right. You've got that guy with his clothespin on his nose. You know, you have the best sensor in the world right on the front of your face, and that's your nose. All of us know what good grain is supposed to smell like. And if you are around a bin or you look into a bin and it doesn't smell good, then there's a problem in the bin, and you need to take the time to figure out what it is, because there's some kind of microbial activity that's giving off odors, and that's a really good indication of a future problem. Hot spots come with certain grain types. Canola is a real problem with hot spots because it continues to respire after it's been harvested. Those hot spots can create all on their own without any temperature or moisture problems from the outside because it continues to heat itself up for a while. Of course, aeration management is your ticket to solving that problem. And then just moisture migration, particularly when we have condensation coming off the roof or a temperature inversion in your bin when there's a change in the weather. That migration may go down the walls and cause that sticking of grain on the sides of the bins and ultimately an avalanche. Some other things that you could check if you're having a problem, or you certainly want to include these things in your management plan for your situation, for your sites for storage. Do you clean your bins when they're empty? Good housekeeping goes a long ways to taking care of that fine material management. When do you inspect for needed repairs or for damage to your bin? Especially steel bins. Every time we load them and unload them, they become looser. They're no longer sealed as well. And if we recycle that bin several times a year, the damage to that bin can be pretty great. So you need to inspect every time you load and unload these bins. Is your reclaim system working properly? Have you cleaned it out lately? What's down in the bottom, or have your bearings been inspected and maintained well? How about the area on the outside of the bins? You have a lot of growth of vegetation on the outside that can catch grain when you're moving grain in and out of the bin. It's amazing the rodent problem that we get just because of grain that's blown into the areas on the outside. And of course, the fire damage when that vegetation dies in the winter and we have a fire hazard at that point. Be sure to check all your handling equipment. Anything that's left, any of that old grain that's left in your handling equipment over the winter or when it's not being used, the insects love to live in that old grain. And we always have a problem with the insects that have harbored over the season in old handling equipment. So those are all things that you need to consider in your housekeeping plan, and if you're having a problem, those are areas that you need to make yourself a checklist and make sure that you've tended to. Do you know which insects you have? If you're especially in the southern part of the United States, insects are something we battle all the time. Knowing what kind of insect activity you have and which insects they are tell you a lot about the quality of your grain. If you know that the kind of insect you see in your bin is a mold feeder, what does that tell you about your grain? It indicates that you've got mold someplace in the bin. These insects don't live where they're not comfortable and have plenty to eat. So it can tell you a lot about the quality of your grain if you can identify what kind of insects you have in your bin. Other things to look for, of course, are leaky structures. That's something that, when it's not raining, you don't know you have a problem. But anytime that you recycle a bin, there's more potential to have leaks in your bin simply because the panels on the bin aren't as tight as they used to be. Look for the bolts that are missing and any cracks that you can see. But look for the caulk joints as well. That's where the surprises happen, where you've had caulking before or insulation before. Maybe it's broken loose. Check your aeration system management. Do you know when it's best to run your aeration system? We'll talk more about aeration later on this morning, but make sure you have a plan and you're up on all the latest with your aeration manufacturer and your contractor. Do you have temperature cables? Do you need temperature cables? And my answer is yes. Temperature cables are really good insurance for any size of bin. That's your first alarm system when there's a problem in the bin. So temperature cables will pay for themselves, and the management of those is broad spectrum. It will depend on your operation, but they're always a good deal. You need to check those to make sure they're not malfunctioning. When that bin tells you it's 255 degrees in there, is it really 255 degrees and you need to be doing some remediation really fast, or is there a cable malfunction? I have a lot of producers and elevator managers that ask me how much air they need for the aeration system. And this is something that working with a good contractor is always a good plan. A good rule of thumb is 1/10 of a CFM per bushel in a steel and flat storage is important. That's a baseline. Concrete upright bins, you can go a little less to 1/20 of a CFM per bushel. More is better, but that gets really expensive in a concrete upright bin. 2/10 of a CFM per bushel is better, and 3/10 is really good. Now, you can't have too much air, and we'll talk about that, but the reason more is better, the 2/10 CFM per bushel and the 3/10 CFM per bushel is better, is that you can cool your grain much quicker. 3/10 of a CFM per bushel cools 3 times faster than 1/10 of a CFM per bushel. And that just means you close the window for problems to begin to form by cooling that grain down quicker. This graphic just shows the time that it takes to take a temperature front all the way through a bin. If we had a 56 bushel or pound per bushel test weight crop and we had 1/10 of a CFM per bushel, it'll take someplace around 150 hours to move a temperature front all the way through that bin. You don't want to stall out a temperature front. It's just like taking the iced tea glass out of the refrigerator in a hot day and setting it on the counter. The temperature difference causes condensation. The same thing happens in your grain bin when a temperature front stalls out in the middle of a grain bulk. So you want to keep that temperature front moving all the way through. That's where your temperature cables play a big part in the management. You can watch that temperature front move through. When you're looking at your aeration system, make sure that it's designed for the product that you're storing. Canola is becoming a really large crop for us in Oklahoma, and some of the problems we've had with the storage hinge from the fact that our bins are designed for the storage of wheat and sometimes corn. As you can see from this graphic, the pore space between canola seed is much smaller than it is with the corn in the bottom picture. That means our aeration system has to be able to push the air through that small space in the canola seed. So that's a design factor that you need to look ahead in your operation to make sure you've thought about the different kinds of grain that you're going to be handling so that your aeration system can be designed according to that need. We look at the static pressure. I referred to that a little bit in the previous slide. Static pressure is the back pressure on your fan caused by the kind of grain you're storing. You can see some comparisons there that the wheat static pressure is 2 times what corn or soybeans is, and canola is 2 to 3 times what wheat is. So if you have a corn bin and you're going to put canola in that bin, that canola bin can put 6 times the pressure load back onto your fan that the corn or soybeans did. That's significant. There's two types of fans. We'll look at pictures of those just quickly today. But when you talk with your contractor, he's going to be throwing some of these terms out at you. There's propeller or axial type fans and centrifugal fans. You need to know which you have because that's important. You need to know which way the air flows in your bin. It's either a suction or a pressure system. You need to know about the distribution system in your bin. Is it going to be ductwork or do you have a full perforated floor? And are you going to control those fans just by manual switches where you go out and switch it on when you think it's time to run the fans? Or are you going to choose an automatic controller? These are all decisions your contractor will help you make. One thing, no matter what kind of aeration system you have, one thing that you can do to help your system work the best is level off that top peak in your bin. Sometimes very difficult to do, and you can always core that bin to level down that top peak. The reason that helps you so much is it gets rid of the fines in the middle, or at least it reduces them, but it also makes your aeration system work more consistently throughout the bin. Air's going to take the path of least resistance, and the path around the shallow side of the grain is a lot easier for that air to get through than the path through the middle and the top peak. So you can save yourself as much as 30% of your cooling time and cost by leveling the top surface of your grain. This is a discussion we could have for weeks and weeks and months. Is which is best, negative or positive airflow? And my answer is it depends. The positive pressure system starts from the bottom and blows air up through the top. A negative pressure pulls air in from the top and the exhaust is down at the bottom. So it's kind of a regional preference and it's a contractor preference. There's good and bad things about both. The bad things or the advantages about a negative airflow system is that it reduces condensation under the steel roof. The other side to that is the way it reduces it is by pulling it down through the grain. So you've got to make sure that you run your fans long enough to get that moisture pulled all the way down through the bottom of the grain. Negative pressure systems are a must when you've got an outside ground pile. They hold covers on so that you don't really have a choice with an outside ground pile. But in a bin, it's one of your two choices to either go negative or positive pressure. Negative pressure also needs larger transitions. Can do roof damage with a negative pressure system. I saw an example of that in Oklahoma recently where it was a co-op system and they had changed out their fans to handle canola. Well, they didn't add extra vents up on top. They had a negative pressure system, which is not recommended for canola either, but this was the system they had. And they actually collapsed some of their roof panels simply because they didn't have enough vent space on top for the new aeration system they installed. Some advantages to positive flow is in a flat storage, your distribution is easier to make more uniform. Flat storages are always a challenge to design aeration systems for, but positive pressure helps that to be more uniform. When you put warm grain in on top of cool grain, you don't pull that heat all the way through the grain as a negative pressure system would. There's less plugging of the floors or the ductwork, particularly if you're handling something that's really dirty or if you're handling a small grain. You can actually pack the floor on a small grain like canola by using a negative pressure system. So it has its advantages and so does negative pressure. You just have to look at your situation and work with your contractor. Here's a picture of the two kinds of fans in aeration. The ones up at the top are axial flow fans and the one at the bottom is a centrifugal fan. If you need to find out which one you have already installed, look at your fan, and if the air makes a 90-degree turn once it enters the fan, it's a centrifugal fan. And that tells you, here's just some statistics about it, but the most important statistic is that a centrifugal fan can build more pressure than an axial flow fan. That's the kind of curve that your contractor will be looking at. The bottom line is an axial flow fan will give you more air but less pressure. The high-end centrifugal fans can do both pressure and flow, but they get pretty expensive. So take-home message is work with a good contractor to make sure that your needs are met for the product you're going to store. Want to look at the efficiency at the place you're going to be working at the fan curve. they'll help you choose that so that you are not spending more money from electricity than you expect. Noise can be an issue, particularly if you're in a populated area. The centrifugal fans are going to keep the noise down. While that's not a grain quality issue, if you've got neighbors that are complaining about when you run your fans, then you're going to have a grain quality issue because you won't run your fans when you need to. So consider some of these other things when you talk to your contractor or dealer about fan selection. Make sure you've looked in your bins when it's empty and you know where the layout is for your ductwork. If you have ducts in different configurations, these are just common configurations that we see. Or whether you have a perforated floor. The perforated floors and the steel bins are becoming more and more popular all the time, just because they distribute the air so well. But you need to make sure that the holes in the floor can hold the seeds that you're going to handle. Again, in Oklahoma, I refer to canola a lot because it provides some real challenges in handling and storage. Sometimes the holes in the perforated floor are too small, and you put a small seed on top of a perforated floor with large holes, and you've got a major problem at that point. Flat storage is getting to be more common all the time, and the aeration system layout and design for flat storage is very tricky. So work with a good contractor that has experience in flat storage buildings. As you can see from the layouts here, the line drawings, the piping is not all the same size. If you have a contractor that quotes all the same size ductwork for flat storage of any size, you need to be questioning what he's doing. It's important that they design these properly or you will not have uniform distribution. When you don't have uniform distribution, you're going to have quality problems within your bulk. What about a hopper bottom bin? We can put aeration in those too. They look like torpedoes that go up along the side of the hopper. Make sure when you inspect that before your contractor signs off on it that they've not installed those torpedoes upside down. This was a situation where a producer had spent a lot of money having this installed in his bin, and had we not caught this upside down ductwork, that would have ripped off the first time he unloaded his bin. So make sure that you know what you're looking for, inform yourself on the product line, and check your contractor's work before he leaves for the day. Now we're going to look at the top side of the bin, and the reason this is so important for grain quality is this is the big problem that we have in large bins especially. 90-foot and bigger bins invariably have condensation problems up under the roof. And it's because of the exhaust vent and the passive empowered vent system on the top. Anytime you blow air into a bin, it has to go someplace. It has to come out someplace. Its job is to remove condensation. And if the air can't get out, then that condensation is going to end up right back down on your prop. If you're pulling air into a bin, it has to come from someplace. So that same vent system is really important for not damaging the roof of your bin. When that fan is sitting there trying to pull air, and if it can't get it from someplace, it's going to pull your roof in. So all of these things are something that have to be sized properly. The large bins, even though we're meeting some of the standards, most of the standards that we've held for all these years, and here's what those standards, those rules of thumb for design look like, I don't think it's big enough. I don't think it's enough for our 90-foot and bigger bins, because the problem calls that I get are in these large bins. I go out and I look at it, and technically they've got enough vent space, but they're still having condensation problems. So if you're putting up a 90-foot or larger diameter bin, spec in a few extra vents, either the powered vents or the inlet passive vents. There's some way to get more air circulation into that bin. Maybe it's a distribution problem. Maybe they're not located in the right place. But you can't shortchange on your vents. This is not the place to save dollars. You'll cost yourself more dollars down the road. Two kinds of vents that you'll look at are gooseneck and mushroom vents. Your contractor can advise you which is better for your situation. Mushroom vents have better distribution, but they're also more affected by wind and other being clogged. So make sure that you discuss the location where your bin is at with your contractor and make that decision wisely. Power bins need to be rated at 200 to 250% of the aeration rate, and they need to turn on before your aeration system does. They can also be run by themselves to evacuate any condensation, so they're a good investment. Just make sure they come on before your aeration system comes on. You're going to have condensation problems to deal with anytime there's a 15-degree temperature difference. So listen to your weatherman, know what the weather report is for the day. That helps you to understand what your bin is encountering. You see a 15-degree difference between the grain temperature and the outside air temperature, then you can expect to have to manage a little differently that day. Now, I'm sure no one on our call-in list here today would do what's been done in this picture. You're better managers than that because you're on the call today. But overfilling a bin is just one of the biggest no-nos that a manager can do. And I know we've all done it. We get one more truckload into that bin. I know we can do it. But we really shoot ourselves in the foot when we do that. If there's any condensation, where is it going to go? It has no place to go but down the wall of the bin. So you have no headspace ventilation. You can't look in through the access points at top to monitor your grain surface. For the integrity of the bin, there's some problems with this. It doesn't maintain its integrity as well when you've overfilled it. But your aeration system just simply isn't going to work in this kind of situation. So don't overfill your bins. Top surface should be level with the sidewalls of the bin. Some monitoring and management tips, I call them the M&Ms of fan management, are listed here. Operate your fans long enough to uniformly cool the entire bin. It's going to be about 150 hours for every 10 CFM per bushel. Aerate as soon as possible after binning. That takes out any harvest heat or any outside temperature differences. If you can, in your area of the country, reduce that temperature down below 60 degrees. It really helps the possibility of keeping that grain in good condition. It also helps the insects to not do damage. In the late fall, run those fans again for a week or so just to get the grain cooled as much as possible, and then seal it off. Watch for condensation and odors, but you don't have to leave those fans open generally during the winter unless there's a temperature change. In the south, of course, for our summer harvested crops, run long enough to cool as cool as you can. Usually in the south in the mid-70s is about the best we can do. And then in the fall, aerate another time to drop that temperature on down as low as possible. If we can get that temperature down below about 40 degrees, we don't have an insect problem, and that's a real gain for us in the south. Fall harvested crops, aerate, binning, monitor for the moisture conditions. The fall always gives us some challenges any place in the United States. This year we've got a lot of wet product going into the bins. So you're going to have to manage a little differently when you've got a wet year. This is what your controllers, if you buy an aeration controller, this is the kind of thing that's programmed into those controllers. Your controller's job is to sit there all day long and do nothing but look at a chart like this in its software and decide whether it's a good time to run the aeration system. Every crop has its own chart like this. This happens to be a corn chart. But this shows you at a certain relative humidity, in this case 70%, and a temperature, in this case 65%, that corn, if we leave it under those conditions long enough, it's going to settle at 14.5% moisture content. So if you're trying to keep your corn at 12%, it's not a good day to run your fan. So these kind of conditions are programmed into your aeration control systems, automatic control systems, and it has nothing better to do than to sit there and watch that all day and do your job for you. Their automatic controllers can be pricey. In the long run, they will save you money. Our economists say that they can pay for themselves in a couple of years. So it's something that you sure want to consider when you're purchasing your aeration systems. On the dollar side of things, you can certainly monitor your aeration systems manually, especially if you have temperature cables, you can hook into a reader and record those manually. Keep it in a logbook so that you catch any temperature changes. Gradual temperature changes probably indicate some kind of microbial activity in your bin. Then we have the data logger systems, where actually there's a data logger that sits there and does nothing but take temperature data all the time. And then the most expensive system, of course, is the computer interfaced automatic monitoring system that can turn the fans on and off for you. Some of the other things that you can do is actually build your own controller. Oklahoma State has some plans out on our website where you can take off-the-shelf parts that will actually be built into a controller without being, you don't have to be an electronics guru to do this, but it can turn the temperature, it takes the temperature readings and turns the fans on and off with that, and you can even install a humidity sensor with that. It keeps track of the hour meters. You can put one of those together for about $150 exclusive of the housing. Some of the other technology that helps you with your grain management is this idea of precision aeration and management. Cross-flow aeration has been installed in some of the big concrete silos, and with the right application, that can be a good thing. Closed-loop fumigation piped in with your aeration system really helps when you do your fumigation for insects a couple of times a year. Moisture sensors within the temperature cables is one of the latest new coming things that you can install in your bins. There's several companies now that offer those, and the moisture sensor is integrated right in with the temperature cable, and your control system can use that information. There's electronic insect monitoring systems that help you detect what your population is doing. Of course, it doesn't count all the insects in the bin, but it will help you to know whether you've got an increase in population or a decrease. And then you have the bioactivity sniffing systems, which actually detect CO2. CO2 is a really early detector, even before temperature, of a microbial activity in your bin. If you can get to the fan exhaust on your aeration system with even a handheld CO2 monitor, you can actually see CO2 levels going up. That doesn't tell you where the problem is, but you know there's some kind of biological activity in your bin. The grain is not going to be putting off CO2 unless there's some kind of microbial activity. So that's a real good early warning system for you. You know, if we don't have a problem in the bin, we don't have to enter generally. So that keeps us safer right there. But we all know there's going to be problems, particularly on wet years. I'm sure the 52 accidents that happened in 2010 and 11, those guys never thought they would be in a problem in a bin. They were just doing their job. So if we do have to go into the bin, we've got to have the proper equipment to do that. And there's going to be other webinars that cover that better than I do. But make sure that you have a harness when you enter a bin. Not only is it the law, it's what we need to do to keep you safe. Your bins need to have anchor points. We'll talk a little bit about that initiative in the next slide. You need a bin entry kit where you've got all of the lifeline systems. Check your air quality. You know, if there wasn't something wrong in that bin, you wouldn't be going in. So you don't really know what's wrong before you go in. There could be some kind of a gas problem in there that you would become susceptible to. And never, ever, ever work alone. When we look at a lot of the incidents that have happened that result in death, we notice these people are working alone, and it was the next day or several hours later before they were missed. And that's a tragedy when that happens. Talk with your family and your employees, anyone who works around your facility. What would they do if suddenly someone didn't show up for breakfast? Or what would they do if they looked into the bin and someone has become overcome with a gas atmosphere or is entrapped somehow? How do you react? Who do you call? What contact info do you have for your rescue team? You don't have time to go find a phone book and look it up and then wonder whether the fire department can even respond to your kind of a problem. So all of this needs to be laid down ahead of time. Hopefully you never, ever, ever have to use it. but when you need it is not the time to figure out whether you have it or not. Cofferdam should be available to every grain bin in the United States. A cofferdam doesn't have to be a big expensive piece of equipment. It can be plywood, it can be trash cans, pieces, anything that you can put around a victim to stabilize that victim and move the grain away from him is what you need to have handy. You need to know where it is and how to use it. Are you building a new bin? This is the time to make sure that's a safe bin. Not only do we design bins to keep our grain in the best quality that we possibly can for dollar reasons and safety reasons, but we need our bins to be designed to be safe bins as well. That even as recent as 2 days ago, the 10 large bin manufacturers came together here in St. Louis. We're talking from the Jeeps conference right now to discuss this idea of what makes a grain bin safe. And we are working on new standards through ASABE that will tell us where and what kind of safety provisions need to come out with new steel bins. Included in those safety provisions will be anchor points, door locations, ladder locations, platform locations, all designed so that the bin provides for a safe working environment. So watch your grain journals and your other industry magazines. There'll be information that comes out about this standard. Hopefully within the next few months we'll see some standards actually go in place for these new bins. The cost doesn't look like it's going to be that much more for these new bins. The bin manufacturers tell us that these kind of changes are not all that expensive, but they can certainly save lives. So how do we fix our grain quality problems? First of all, we focus on all the details that we've talked about. We have to manage the grain quality after we put it into the bin, because it does only one thing, and that's get worse. Be prepared through the communication and the teamwork with your employees and with your families. They also have that sensor on their face too, and they need to feel like when something is not right to them that they can come to the management and say, we have a problem, we need to check on it. That's the time to remedy a problem, not after an incident has happened. So training is everyone's job. It's your job as a manager, it's your job as an employee to seek out training to keep yourself safe and to make the most money you can for your company. Fewer accidents or incidents. We don't call them accidents anymore, they're incidents. We have fewer of those, we have a better product. Of course, when you've got a better product, you make more money. So grain quality and safety, that's a winning combination no matter how you look at it. It's a win-win for everybody. It's a combination for success. So at this point, I think we can take some questions. Do we have some questions that have come in?
And I put one out there for the start of it, and feel free to anybody on the line to go ahead and type in your questions. And actually, we will try to do a *4 on our phone here on our side to open up for verbal questions. So if anybody is more comfortable asking that question, we're going to try to take them over the phone as well.
The conference is now in talk mode.
Okay, I have one question here. Are there any issues if you overfill a bin and then pull some out shortly after to level off? The second part of that question is, does this or does this not also help with coring the bin? The answer is yes and yes. The first part of that question is there a problem with overfilling the bin? Not if you level it out quickly. If you've got a temperature front that comes through and you haven't pulled that top level down to the wall height of your bin, then you can have some problems. But if you fill it and then core it immediately, I'd say within the next 5 to 6 hours, you don't really risk too much of a problem. The coring certainly helps level that top surface, and it also removes the fines out of the bin. So I've seen that be a good practice as long as you core enough to bring the top level of the grain down below the eave height on your bin. Good question. Next question. I guess everybody's just doing such a great job out there. Next time you need to be giving this webinar. That's a good deal. I'm glad you're not having those big problems. Maybe with some of the precautions that we talked about today, you won't have those problems. That's the goal.
Very well. For those out there who do all appreciate you joining our webinar today, and we will work on having this posted on the website in the future, so we can always come back and reference this valuable material. So thank you all for joining us today.
Thank you.